All right, today we're tackling one of the most powerful tools ever invented by humans, calculus. And believe it or not, we're going to use it to answer a question that pretty much every business on the planet is obsessed with.
So here's the big question. It really feels like a mystery, doesn't it? If you set your price too high, nobody's going to buy your product. But if you set it too low, you're just leaving cash on the table. So finding that perfect sweet spot, that peak of the profit mountain, well, it's not just guesswork, it's math.
And the key is speaking the language of change, the language that describes how things move and shift, like how your profit changes when you just tweak the price a little bit. That language is calculus. It's kind of like the secret code running behind everything, describing the world from how an economy grows to how a planet orbits the sun.
Okay, so the first half of this language is something called differentiation. The best way to think about it is like a super powerful microscope. It lets us zoom all the way in on one single moment in time to see exactly what's happening right then and there.
And the key word here for sure is instantaneous. Look, it's pretty easy to figure out your average speed on a road trip, right? You just take the total distance and divide it by the time. But a derivative? A derivative is like glancing down at your car's speedometer. It's not telling you your average speed over the last hour. It's telling you your speed right now, at this very second. That's the incredible power of a derivative.
So how do we actually find this instantaneous change? Let's just walk through it together. First, just picture your company's profit as a nice curve on a graph, okay? Now, step 2, pick any single point on that curve that you're curious about. Now for the cool part. Imagine drawing a straight line that just barely kisses the curve at that one single point. That's what we call a tangent line. And the steepness of that line, its slope, well, that tells you the momentum of your business in that exact moment. If that slope is super steep and positive, hey, profits are booming. If it's negative, they're shrinking. And what if the slope is perfectly flat, a value of 0? Well, you might just be standing at the very top of the mountain.
Now, the really good news here is that we don't have to sit around guessing what these slopes are. For hundreds of years, mathematicians have worked out all the rules for us. So for example, if your profit happens to follow a simple curve like x squared, its rate of change, that's its derivative, is just 2x. Super simple. And what about a constant number? Just a flat line on a graph? Well, a constant value doesn't change at all. So its rate of change is, you guessed it, 0. This table just shows a few more of these really handy shortcuts.
Okay, let's switch gears and look at the other half of our language. This is how we build everything back up. You see, if differentiation is all about breaking a problem down into its tiniest individual moments, its counterpart, integration, is all about adding all those moments back up to see the whole grand picture.
And this slide really shows the beautiful symmetry here. I mean, they are perfect opposites. Think about it like this. Differentiation is like taking out a magnifying glass to inspect the slope at one tiny point on a curve. Integration, on the other hand, is like taking a crayon and shading in the entire area underneath that curve to see the total sum of everything.
So let's jump back in our car for a second. Remember how the derivative was our speedometer reading at every single second? Well, integration is like taking all of those individual speedometer readings from your entire trip, every single one, and just adding them all up. And what do you get when you do that? You get the total distance you traveled. See, it reconstructs the whole story from all its little moments. That's exactly what an integral does.
Okay, so now we have our two main tools, right? We've got the microscope for looking at tiny moments, and we've got the wide-angle lens for seeing the total picture. So, how does this actually help us find that perfect price for our product?
Let's ask a really practical, down-to-earth question. Let's say you've already made 1,000 of your widgets. What exactly is it going to cost to produce widget number 1001? I'm not talking about the average cost across all of them, but the specific extra cost of making just that one next unit. Well, in economics, that has a special name. It's called marginal cost. And guess what? It's just a derivative. It's nothing more than the derivative of your total cost function. It gives you the instantaneous rate of change of your costs at the very moment you decide to make one more item. Calculus gives us a precise, powerful answer to this absolutely crucial business question.
And this is really where it all comes together. We can use the exact same logic for the money we're bringing in. That extra cash you make from selling one more item, we call that marginal revenue. And yep, it's the derivative of your total revenue function. Now, here's the magic. As long as the money you get from one more item, your marginal revenue, is higher than the cost to make it, your marginal cost, you should definitely make another one, because you're still making a profit on it. But at the exact point where the cost of making one more is equal to the money you get from selling it, you stop right there. That is the peak of the profit mountain.
And this whole relationship works in reverse, too. It's so cool. If all you have is data on your marginal cost for each item you produce, you can use integration, our summing up tool, to perfectly rebuild your company's entire total cost function. See? Differentiation and integration are always in this constant, perfect conversation with each other.
All right, so let's just zoom out one last time and really appreciate what we've just uncovered here. Calculus isn't just a bunch of abstract numbers on a page. It's a totally dynamic way of seeing and understanding the world.
These two core ideas are really like the yin and yang of mathematics. Differentiation lets you see the atoms of change, the tiniest individual pieces. And integration? Integration lets you see the entire universe that those atoms build. One breaks things down to understand the smallest detail. The other builds them back up to understand the grand design. Put them together, and you get this profound way of understanding any system that changes over time.
So, the next time you see a price tag, or you look at a company's growth chart, or really any dynamic system that's in motion, you'll know the secret language that's describing its journey. So the real question is, now that you know the language of change, what will you analyze?